Okay, so I'm going to do section 4.3 today, and it's going to be, well, for me, a heavy calculator section. If you can do these things in your head, that's more power to you. I could do a lot of them in my head, but I'll really focus on my calculator. And there's a few problems in this section that just turn out to do more harm than good. Problems 44 through 54 kind of introduce some theory, although they don't look like theory problems, and that theory turns out to really confuse students more than it's worth, and it's the kind of theory that we usually ignore after we introduce the theory. So I'm just going to totally skip those problems. If you have a strong desire to see those problems worked out, just shoot me an email or come visit me and I'll show you how to do them. So I'm going to skip 44 through 54 just completely. And then we're going to be dealing with square roots, cube roots, fourth roots, fifth roots in this section. Roots are with the double period, I suppose. And we're also going to do a bit of graphing. You certainly don't need graph paper to do any of the graphs that we do in this class. I just went to the internet and searched blank graph paper and found this and printed out a bunch of these just so it'll make my graphs a little bit nicer and hopefully easier for you to follow what I'm doing when I'm graphing. So if you wanted to do that, that would be fine. If you just want to draw the graph yourself, you don't need to have that accurate of a graph. You don't need graph paper, but I'm going to use it. And then should talk just for a little bit about roots or radicals. Like I will use the words roots and radicals more or less interchangeably. So we're going to have different symbols. This is, I would call, a square root symbol, hence the name root. Sometimes people call that a radical sign. When I put a little 3 in the little cup there, it's called a cube root symbol. Maybe cubed root would be fine. When I put a 4 there, it's called a fourth root symbol. When I put a 5, it's called a fifth root, and so forth. When you put a 6, it's called a sixth root. And then you'll notice that most of the radicals that I wrote had numbers, and there's an implied number in the square root that's not a 1. The implied number in a square root is called a 2. Each of the numbers that I wrote is called the index. So a square root, we say the index is 2. In a cube root, we say the index is 3. In a fourth root, the index is 4. And in a fifth root, the index is 5. My calculator has the ability to do square roots, cube roots, fourth roots, fifth roots, sixth roots, and seventh roots. It goes on forever what it can do. The thing that we put under the radical is called a radicand. There is no radicand written in this, but the radicand, hence the name radical, is the, I'll say, the expression that's under a radical. So those are some definitions. A square root asks, what it's asking me for is what number squared equals the radicand. So if I gave you something like the square root of 25, this basically is asking what really asks for a positive number. So what positive number squared, because the index is 2 squared, equals 25, and the answer is 5 because 5 squared equals to 25. The answer isn't negative 5, even though negative 5 squared also equals 25. The symbol for a square root, it wants the positive a number that when you square it you get the radicand. And if I didn't know that the square root of 25 equal to 5, then my calculator knows that. And on my calculator, to do a square root, there's the square root button. I hit the square root button, type in the radicand, and it will tell me the square root of 25 is 5. For something like this, the cube root of 64, cube roots don't emphasize positive or negative, because negative numbers, when you cube them, you get a negative number. You can't get the number under the radical. But so this is just asking me what number cubed, hence the cube root, equals 64. It's not 8, because 8 times 8 times 8, which is 8 cubed, doesn't equal 64. The answer to the cube root of 64 is 4, because 4 to the third power is 64. My calculator has a built-in cube root feature, and to figure that out, if I didn't know it in my head, I'd yank my calculator out. I'd hit shift and square root, and when you hit shift and square root, it gives you a cube root symbol, and then I would type the number 64, and my calculator will tell me that it's equal to 4. One quick more calculator exercise, and I'll do a lot more calculator as I go through this section. If I ask you to find the fourth root of 81, this asks me what number, really technically wants what positive number. So when the index is even, it wants a positive number. When the index is odd, it's not so picky, because you don't get the conflict, because both negative 5 squared and positive 5 squared equals positive 25. I pick the positive. Similarly, when you take two numbers and raise them to the fourth power, you get the same positive number, whether they're positive or negative. So what positive number to the fourth power equals 81? And so, again, if I don't know that 3 to the fourth power is 81 and the answer to the fourth root of 81 is 3, I could do it on my calculator. It's a little trickier on my calculator. My calculator doesn't have a specific fourth root feature. So on my calculator, to get the fourth root of 81, I look at the exponent key, and right above it there's a template that allows me to put any index I want. I could put a 3 there if I wanted. So to do the fourth root of 81, I'm going to go shift and hit the exponent, the x with the square key, and that gives me a template that I can type in any index. So I could even do cube roots this way. I could actually do square roots that way if I typed that as a 2. But I'm going to do a 4 and then arrow in under the radical and type 81 and get 3. So these features on my calculator I'm going to use a lot. So the square root key is just hitting the square root key. The cube root is shift and square root key. And then for anything other than a cube root, fourth root, fifth root, sixth root, seventh root, I hit shift and then the x with the exponent key. And well, after I clear out what I have in there, and then that gives me the template to type in any root that I want to. So most every problem in the first half of section 4.3 can be done on your calculator. Quite honestly, if I can't do it in my head, then I'm going to do it on my calculator. I happen to know a lot of the roots, and I can do them in my head just because I've taught the class for 20 years. I should know, bit of something. But if you're not familiar with the roots, then just use your calculator. So I'm going to jump into the section now. The first problems between 1 and 30, I can do them either in my head or on my calculator. Even if I could do them in my head, I'm going to confirm on my calculator to make sure I'm not getting the wrong answer. So 2 asks me what positive number squared is 16, and I know that's 4 because 4 squared is 16. The answer is just going to be the number 4. I don't need to show any work if I use my calculator, if I do it in my head. On my calculator, I've just typed the square root button, type 16, it equals, and it'll tell me it's 4. problem 4, the negative in front of the square root really means -1 times the square root of 36. And the square root of 36 asks me what number squared is 36. And because 6 squared is 36, the square root of 36 is 6. This is -1 times, I think of it as -1 times 6 if I'm not just resorting to my calculator. And the answer for number 4 is going to be -6. On my calculator, I would just hit the negative in the parentheses, hit the square root key, type the number 36, and my calculator would tell me that my answer that I did without my calculator is correct. 6 is not a 7th root. For it to be a 7th root, the 7 would have to be kind of up here or in the little cup. My calculator kind of puts it above, but it would be kind of a subscripted number. This actually, problem 6, means 7 times the square root of 25. And order of operations with square roots is you treat the square root like a parentheses and get it done first, and then you do any multiplication that's left over. The square root of 25 asks me what number squared is 25, and 5 squared is 25. So the answer to problem 6 is going to be 35. And again, I could just do this on my calculator without thinking. I'm just going to make something look just like that. I'm going to type the number 7. I'm going to hit the square root key. My calculator understands that means 7 times the square root of, in this case, 25. And I match up with my 35 perfectly. So I can go through the first 30 problems in a minute, I think, because I could answer these pretty darn fast on my calculator once I'm good at them. So 8, I know, because it says what number cubed is 27 is what this is asking. And if you know that 3 cubed equals 27, then you can write the answer of 3 down without breaking out your calculator. It's not x equals 3, there's no variables in the problem, just cube root of 27 is 3. If I did this on my calculator, I'd hit the shift button and then the square root key, because that's where the cube root template is hidden, and then I type in 27, and my calculator would tell me it's 3. 10 is asking me what number cubed is -125. And it turns out that -5 cubed, which equals -5 times -5 times -5, is -125. So if you can look at these and know these, then I wouldn't use my calculator. If you can't look at them and know them, then just use your calculator. It's not that important to know a bunch of radical powers when your calculator can do them for you. So I'm going to go shift, and then the negative I need is a negative under the fraction, and then 125. And then my calculator will tell me the answer to this is -5. The 12 is saying this really means -1 times the cube root of -27. The cube root of -27 is asking me what number cubed is -27, and -3 cubed is -27. So orders of operations for radicals is you treat the radical like a parentheses, get it down to a single number first, and then any multiplication that was outside the radical you do. And the negative outside the radical means multiply it by -1. -1 times -3 is going to give me +3 for an answer to 12. And again, there's no reason to do this without your calculator. If I can't do it in my head, like by myself, I'd just look at this and I'd write the answer down. If I have to do any work by hand, I might as well just use my calculator because it's probably more accurate and quicker. So negative, shift and square root for the cube root, and then -27, and I'm going to get the 3 that I have down. (16) Which number cubed is 1? And the answer is 1 because 1 cubed is equal to 1. 1 is a nice number because regardless of what the index is, it's its own root. And again, if I don't know this, shift cube root 1, and then I get 1 for an answer. For 16, it's not hard to enter on my calculator. The square root of a fraction, you do the square by hand, you do the square root of the numerator and leave that number in the numerator. You do the square root of the denominator, you leave that number in the denominator. The answer to this is going to be 7 over 5 because the square root of 7 is, the square root of 49 is 7 and the square root of 25 is 5. Again, if you don't know those in your head, pull out your calculator, hit the square root button, then hit the fraction key. In the numerator, put the number 49. In the denominator, put the number 25. And your calculator will tell you that it's 7/5. For 18, the cube root of a fraction, you do the cube root of the numerator over the cube root of the denominator. The numerator asks me what number cubed is 8. Because 2 cubed is 8, the numerator, the radical sign is going to drop and turn to the number 2. The denominator asks me what number cubed is 27, and because 3 cubed is 27, I'm going to drop the radical sign and write a 3. Again, on my calculator, I would just enter this, and it's going to give me the answer if I can't do it in my head. And then again, even if I think I could do it in my head, on a test I might use my calculator anyways, just in case I'm thinking wrong. So calculator, shift, square root to get the cube root, fraction key, 8 in the numerator, 27 in the denominator, and I get that 2/3 that I said my answer is. 20 says what number to the raised to the 4th power is 81. I think I did this already. And because 3 to the 4th power is 81, the answer to number 20 is going to be 3. And again, on my calculator, that's a little trickier. I hit the shift and then the X with the square button to get the template so I could put a 4th root in. And I do 4th root, arrow under, and get 81. And my calculator will tell me that it's 3. 22 and 24 should be easy to do in my head because I know what the radical equals. 22, this means 2 times the 4th root of 81. The 4th root of 81 is still 3, so this means 2 times 3. The answer to 22 should be the number 6. Again, on my calculator, it's a little tricky on my calculator. If I don't put the times sign, I think it's going to mess me up. But when I do this, if I go 2 and then go shift and hit that key, all of a sudden it makes it a 2nd root. So to keep that from happening, because I want that to be a 4th root, I have to go 2 and then hit the times key. Once I hit the times key, it'll allow me to get the template. Without the times key, it shoves the number that I typed into the index, and I don't want that to happen. So on this, on your calculator, in order for you to get both the 2 and the 4th root of 81 being multiplied, you need the times key. And then that'll give me the same answer of 6 that I got by hand. 24 means -1 times the 4th root of 81. All 3 of these problems have the 4th root of 81, and the 4th root of 81 is always 3. And so the answer to problem 24 is -3. I might be able to enter this on my calculator without having to use the times sign. I know I could enter this. I'm going to try them both. This one I'm going to do first, and then I'll try that one. To do this one, I'd go negative in the parentheses 1 times shift and the X with the square key to get the exponent template, and then 4th root of 81. gives me the -3. I think I might be able to enter this one because it's the negative sign probably is not going to go into the index. So I'm going to try to enter this going the negative sign and then shift radical and at negative state where it should. 4th and 81. So get the -3. It's when you're multiplying by a number that's not a 1 or -1, then you need the times sign on your calculator. I know that answer is -3 because -3 to the 5th power is -243, and this question is asking what number to the 5th power is -243, and it's -3. If I don't just know it, I go shift, template for the radical, 5th root, and then negative in the parentheses, 243, and I get the answer of -3. That's all I would write on my test. If this was a test question, that's what I think in my head to help me understand what the answer is, but I would just write that number. 28 is 3 times the square root of 49. The square root of 49 is 7, so this is 3 times 7. The answer should be 21. I can enter that just like it is. So I can go 3 square root 49, and my calculator will give me the 21. And the last ultra easy problem, 30 means 5 times the cube root of 64. The cube root of 64 asks me what number cubed is 64. Because 4 cubed is 64, this is 5 times 4. And the answer is 20. By hand, I think I could enter this just like this because there's a template for the cube root. So I'd go 5, and then shift square root for the cube root, and then type 64, and get the answer of 20. It's only like for 4th roots, 5th roots, 6th roots, when there's times in them, you need the time sign. The next few problems are asking me to give a decimal approximation for a radical, and do any of these problems, yeah, they all will come out to decimals, and it says round to 4 decimal places. So this is not terribly hard, other than you might have forgotten how to round. So each one of these isn't a perfect square. I don't know of any number that's squared that equals to 6, and it's an ugly decimal number that squares that equals to 6. And my calculator will give me about 9 decimals. It turns out there's infinitely many decimals of the number that's squared that equals to 6. I'm just supposed to give you 4 of them. So the square root of 6 I can only do on my calculator. Well, back in like 1980, these calculators, well, they just started to exist, but they were crazy expensive. And as you know, my parents didn't have money. I didn't have one of these calculators, and there were tables and books that you could use to get radicals, and then there were techniques to get square roots reduced by hand that were really unpleasant. It would take you about 10 minutes to figure out 4 decimals for 1 square root, and we don't have to do that anymore, thank gosh, because these calculators are so cheap now. So, oh, look what my calculator did. Square root of 6, and it gave me the square root of 6. This calculator, when we get to the next section, you'll really like that when you type a square root, it doesn't give you a decimal, because that's actually generally preferred. But when I'm asked to give a decimal, and this calculator doesn't give me a decimal, this SD button, if you just press the SD button, I think it means standard/decimal, will give you the decimal that you want. So for an answer, I have to consider 5 decimal places, and the number in the 5th decimal, if it's 5 or bigger, tells me to round up. So for each one of these problems, I'm going to focus on the number in the 5th decimal place. If it's 5 or bigger, I'm going to round up. If it's 4 or smaller, I'm going to leave the 4th decimal alone. And my answer to this is going to be 2.4495. I needed to round the 4 up. The next one I'm going to do 3 square root of 5. My calculator is going to produce another 3 square root of 5. So I hit the SD button right above the delete key, right next to the right parentheses, and I get 6.70820. Again, I look at the number in the 5th decimal place. If it's 5 or bigger, I round the number in the 4th decimal place up. If it's 4 or smaller, I leave it alone. So my answer to 34, I'm not going to round up that 2 because the number after the 2 isn't big enough to force it to round up. For 12, I do shift cube root of 12. It'll give me this as a decimal. For 5 decimals, it's 2.28942. The number that tells me whether to round up or not round up is a 2, and 2 is not big enough to cause me to round up, so I'm going to leave this just like that. I'm not going to round the 4 to a 5. So the answer I'm going to write for 34 is 2.2894. For the 4th root of 20, it's kind of overkill on calculators. When I initially wrote these problems, the calculators that were available were quite a bit harder to use, and so my students needed a lot of training on calculator work. But this calculator just kind of changed everything. It's made calculator work just so effortless, really. So my answer for 20 is going to be 2.1147. I don't round that 7 up because the number in the 5th decimal place isn't big enough to cause me to round it up. For 40, I go 3, and then I need the times key. If I don't put the times key, it's going to frustrate me. And then shift, template for the 5th root of 40. My calculator gives me 6.27383. The number in the 5th decimal place again tells me not to round up the 8 in the 4th decimal place to a 9. I'd only round up if the number that I'm boxing is a 5 or larger. And then the last one, I'm going to need the SD again. So 4 plus 3 square root of 6, enter, SD 11.34846. The number in the 5th decimal place, because it's 5 or bigger, I'm going to round that up to a 5. And in my answer, I'm going to write 11.3485. So that gets us to the group of problems where we're skipping. So the group of problems that we're skipping are 44 through 54, and that would be the next problem. So I'm going to get all the way down to 56 next. Again, if you have any desire to see how 44 through 54 should be solved, come visit me and I'll show you. It's not terribly hard, but it's, like I said, there's some theory in it that kind of messes things up. The next thing, group of problems, I start to see the letters, and to simplify the square root or 4th root or cube root of a letter, for a letter, you divide the exponent by the index and drop the radical. So for letters under a radical, just for now, just divide the exponent of the letter by the index and drop the radical. So these are actually going to be really quick and easy as well. For 56, I need to separately do the square root of 16 and the square root of b squared. The square root of 16 my calculator can do just fine. The square root of 16 is the number 4. When I take the square root, I drop the radical. So part of my answer to 16 is going to be 4. The other part, to deal with the letter, I divide the exponent by the index. And in a square root, the index is 2. So I'm going to take the exponent 2 divided by the index 2. And when I do that dividing, I drop the radical. And for an answer for number 56, I'm going to get 4b. I could check it if I want to. I generally don't check. But to check this, whatever I say is the answer to a square root problem, I have to be able to square it and get what's under the radical, because that's what it's asking me. What squared is 16b squared? And to square this, I'd square the 4 and I'd square the b. That's a strategy that we learned back in chapter P. This would give me 16b squared. And so I know my answer is right. For 58, to do the square root of any letter, you have to divide by 2, because in a square root the index is not written, but it's assumed to be 2. So in 58, the answer is going to be y to the 5th. And again, I could check that as well. If I wanted to check number 58, for a square root, my answer squared has to be what's under the radical. And to square y to the 5th, you're going to multiply the exponent by 2 and get the y to the 10th. So for each of the problems between 55 and 78, I'm going to do the numbers and the letters separately. The numbers, if I can't do them in my head, I'll use my calculator. And the letters, I'm going to divide by the index. Square roots are the only ones that are a little bit tricky because the index is 2 and it's not written. For 60, I have to think of this as the second root of x to the 12th, because in a square root, the 2 is not written, but it's assumed. So this is going to be x to the 12 over 2 power, and my answer is going to be x to the 6th. For 62, it's going to be y to the 12 over 3 power, and my answer is going to be y to the 4th. I'm not going to check these, but they're easy to check. Well, let me check this one. To check this, for an answer to a cube root, whatever I say the answer is, I have to be able to cube it and get what's under the radical. And y to the 4th cubed is y to the 4 times 3, which is y to the 12th. So it works just perfectly. In the next section, we'll learn the evil twist to this. The evil twist is when you divide, there's a remainder, there's something different you have to do. All the problems in this section, with the letters, the dividing, you don't get a remainder, they're the easier problems. In the next section, they get a little harder, but not that hard. In 64, I have to do separately the square root of 36, which I can do in my head or by my calculator, and the square root of 20. The square root of 36 turns into the number 6. And for the x to the 20th, because it's a square root, I'm going to divide the index by 2. And for my answer, I'm going to get 6x to the 10th power. For 66, I'm going to do the cube root of 27 times the cube root of y to the 9th. Y to the 9th. For the cube root of 27, shift square root for the cube root feature. The cube root of 27 is 3. And for the y, I'm going to divide its exponent by 3. And my answer to 66 is going to be 3y cubed. 68, I have to do the 4th root of 16 times the 4th root of z to the 4th. Shift x with a square for the template for the 4th root, and then 4th root of 16, which is 2. And for the z, I divide its exponent by 4 and get z to the 1st power. My answer is going to be just 2z. 70, square root the 9, square root the x to the 10th by dividing its exponent by 2, and square root the 16. These are almost insulting to use the calculator for. So square root of 9 is 3. For the x, I'm going to divide its exponent by 2 and get an x to the 5th. The square root of 16 is 4. So for my answer to problem 70, I'm going to get 3x to the 5th over 4. These are, silly in some sense. So 4th root of 256 for 72 times the 4th root of x to the 4th over the 4th root of y to the 8th and the 4th root of z to the 12th. That's, I think, is 4, but let me make that certain. Shift x with the exponent for the template for that 4th root of 256. That turns into the number 4 without a radical. Then for the x, I'm going to divide its exponent by 4. The y, I'm going to divide its exponent by 4. And the z, I'm going to divide its exponent by 4. For my answer, in the numerator, the x is going to have an exponent of 1, so I'm just going to write 4x. In the denominator, the y is going to have an exponent of 2. The z is going to have an exponent of 3. Got to be getting close to the last one of these. 74. I need to do the square root of 9, the square root of x squared, the square root of 49, and the square root of y to the 4th. And then for the letters, I put the index in so I know what to divide by. For the numbers, I know that the square root of 9 is 3. For the x, I divide its exponent by 2. And the denominator, the square root of 49 is 7. For the y, I divide its exponent by 2. And the answer I get for 74 is going to be 3x in the numerator, or 3x to the first power, and then 7y squared in the denominator. Got a little crazy with these, I guess. 76, 4th root of 16 over 4th root of 81 times the 4th root of y to the 4th times the 4th root of z to the 12th. 4th root of 16, shift x with the exponent, 4th root 16 turns into the number 2. That's the only thing that's going to be in the numerator. In the denominator, 4th root of 81, if you do it right, turns into the number 3. For the y, when I divide 4 by 4, I'll get y to the first power. For z, when I divide 12 by 4, I'll get z to the third power. So my answer for 76 should be 2 over 3yz cubed. And then in 78, I do the square root of 1 over the square root of x squared. 1 is its own square root. If you do square root of 1, you'll get 1 without a radical sign. So that's part of the answer. And then in the denominator, you divide the exponent of the x by 2, and you'll get x to the first. And gives me 1 over x. Next group of problems are graphing problems that I'm going to yank out my graphing calculator. And in addition to graphing, they want me so the instructions are complete the table. The table is going to give me points. And then I'm going to plot the points. I'm going to sketch a graph. And then I'm asked to find the domain and range in interval notation. We used to cover this in intermediate algebra in chapter 3. Now that skill has been moved to beginning algebra. If you don't remember how to find the domains and ranges of graphs, I think I'll do enough in my videos that you'll be able to do it. But if you want to review that, I believe it's section 3.2 in my videos. It's a chapter that says skip because it's a chapter, like I said, we used to cover it, but we don't cover it anymore. So if after watching me find the domains and ranges for all the graphs, if you don't like, if you're not sure, you can watch the video from section 3.2, which is still posted, or you can come visit me and I'll show you how to do it. So these are technically easy problems. I give you a table and I'm going to fill in the table. The first thing I'm going to do is for each number in the x column, I'm going to find a y, which I'm calling h of x. So the first one I'm going to do square root of 6 minus 2. Let's use my calculator. Square root of 6 minus 2 equals to 2. So that's going to turn into a point, and that's going to actually be the point x equals 6, y equal to 2. In a bit I'm going to graph that. Now when I do 5, I get the square root of 5 minus 2. And the square root of 5 minus 2, I'm going to SD it, because it gives me the square root of 3, which is not helping me for graphing. And it does, so it's round to 2 decimal places, so I'm going to write 1.73. Quite honestly, 1 decimal place is probably all I could really plot in terms of accuracy. So the second point I'm going to plot is 5 and 1.73. And then I'm going to do the square root of 4 minus 2. So square root 4 minus 2, SD it, and get 1.41. That's going to give me the point 4 comma 1.41. And then the square root of 3 minus 2, it's going to be 1, which is 1. Then I'll plot the point 3.1. And then the square root of 2 minus 2, which is going to be 0. So I'll plot the point 2.0. And then the tricky ones. The square root of 1 minus 2 asks me to find which number squared is -1. And the problem is when you square anything, whether it's negative or positive, it turns positive. My calculator is going to give me some sort of error message, because square roots, unlike cube roots, you can't find the square root of a negative number unless you learn something from section 410. It turns into something called an imaginary number, but that's too early. So I'm going to do the square root of 1 minus 2, and my calculator tells me math error, which means there's no number that when you square it, you can get -1. And so this right here is not going to be graphable. I don't know how to graph something that doesn't have a y. And similarly, the next one, the square root of 0 minus 2, is really the same thing as the square root of -2. And again, square roots, anytime I see a square root, it asks me what number squared is the thing under the radical. And any number, when you square it, when you square a negative, you get a positive. When you square a positive, you get a positive. I'm going to get an error message for this again, and this won't be a point on the graph. So again, so if I did this, clear this out, square root of 0 minus 2, I get the same error message. So these are all the points I can graph. These aren't going to be on my graph. And it's actually going to help me when I go through this. So now I'm going to break out my graph paper, and I'm going to plot the points 6, 2, 5 and 1.73, 4 and 1.41, 3 and 1, 2 and 0. The other points were 1 in error, so that won't be graphed, and 0 in error. That won't be graphed either. So the best I can, I'm going to plot these points now. So on my grid, 6, 2 is about here. I can label it. When I start labeling the points, my graph gets pretty ugly, but I'll do it for first. 5 and 1.73. 5 is easy to find on the x-axis. 1.73 is somewhere between 1 and 2, and it's more than 3/4 of the way up, so more than half the way up, or it's about 3/4 of the way up. So I'm going to call that point the point 5 and 1.73. And then 4 and 1.4, I find 4 on the x-axis. 1.4 is a little bit less than 1.5, so I went a little bit less than halfway. We don't have to be that accurate with our graphs. 3 and 1, I'm going to plot but not write the point, because it's, again, I write too big and I run out of room. And then 2 and 0 is the last point that I have. And then anything to the left of 2 they're all going to give me errors. If I made this table bigger and included a -1, a -2, a -3 in the x column, I'd get more errors. So my graph is actually going to start right here, and it's just going to go up forever. Again, so square root graphs, most of our square root graphs are going to look just like this. So this is the best I could do with making a table and doing a graph without having a graphing calculator. So I've made my table of values, I've sketched a graph. Now I'm going to find the domain and the range. For the domain, I look at the x-axis and see where the graph starts and where it ends. Well, the graph starts at x equal to 2 because it doesn't exist to the left of 2. So for my domain, I'm going to put a square bracket at 2 followed by a comma because that's where the graph starts. And then I didn't do more points, but if I did 7, I would have gotten a y. If I did even 100, I would have gotten a y. Turns out the graph is going to go forever to the right. Like for instance, if I did 100, I'd do the square root of 100 minus 2, and I'd get 9.89 or 9.90, I guess. So the graph doesn't end to the right. It goes forever. It goes to the far end of the right axis, the far end of the x-axis, and the far end of the x-axis is positive infinity. So the end of my domain, reading this graph from left to right, it goes from x equal to 2 all the way to x equal infinity. And because it physically goes through 2, I get a square bracket there. It goes on forever. You can never actually get to infinity. It's proper to put a round bracket on the infinity. The next thing I'm going to do is look at the y-coordinates of the points to find the range. For the range of this, I need to identify the bottom of the graph. And this is the bottom of the graph. And the point at the bottom of the graph is the point 2, 0. For the range, I'm looking for y's, whereas the domain, I'm looking for x's. For the domain, I read from the left edge of the graph to the right edge of the graph. For the range, I read from the bottom of the graph to the top of the graph. And in this particular graph, the bottom of the graph, its y-coordinate is 0. It doesn't look like it, but this graph is going to keep going up forever, very slowly, but eventually it's going to get off my page. It's eventually going to get to the top of the y-axis, and the top of the y-axis has a y-coordinate of infinity. And for the end of my range, just like for the end of my domain, I'm going to put infinity. I'm going to do lots of domains and ranges, so eventually I think you'll get good at them. But this probably definitely isn't enough for you to understand how to do every domain and range that I ask you to do. All right, so something that I should probably exploit is my calculator can make tables, and let me get this table done with my calculator. And well, heck, I'll do it on the next one. Eventually I'm going to use my calculator to make tables, because my calculator does tables so much nicer than I can do them by hand. So 82 gives me a cube root. I give you the table to fill in. So I ask you to make a table of values and sketch a graph. So I'm going to start off by doing this table. First thing I'm going to do is do the cube root of -5 plus 3. So shift cube root -5 plus 3, and I'll get -1.26. So that's going to give me the point -5, comma -1.26. The second one I'm going to do is the cube root of -5 plus 4. I'm going to exploit that back arrow, so I'm going to go back, delete, change this to a oh, I wrote that wrong. I should have written the cube root of -4 plus 3. Messed up there, because I was supposed to just change that x to a -4, so really messed up. So the cube root of -4 plus 3, is negative 1. So the next point I'm going to plot is the point negative 4, negative 1. And then I'm going to do the cube root of negative 3.5 plus 3. I'm going to go back arrow, delete the 4, type in a 3.5, and I get, negative 0.79. I could have the 0. I don't need the 0, but I need the 0.79. And then for negative 3, I get the cube root of negative 3 plus 3. So again, I'm going to exploit my calculator. Back, back, back. Delete, delete. That's that. Gives me 0. So I'm going to plot the point negative 3 comma 0. And then I'm going to do the cube root of negative. This is overkill on the points, but that's okay. And then back, 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 back. Delete 2.5. I get 0.79. So that point's going to be negative 2.5 comma 0.79. And then I'm going to do the cube root of negative 2 plus 3. You'll start to see similarities. So back, 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 delete, delete. There's negative 2 plus 3. And I get 1. That's going to be the point negative 2 positive 1. And then the cube root of negative 1 plus 3. So back, 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 delete, type in a negative 1, and I get 1.26. That's the point negative 1 comma 1.26. Oh, getting tired of these. Cube root of 0 plus 3 and the cube root of 1 plus 3. The cube root of 0 plus 3, delete, delete, 0 is 1.44. That's going to be the point 0 comma 1.44. And then the last one, the cube root of 1 plus 3 is 1.59. So that's 1 comma 1.59. Let me just do a dumb one just to help you with something. If I did like 100, the cube root of 100 plus 3 it's going to give me 4.69 for the y. And we're not going to be able to plot that, but that's going to help me understand the range a little bit better. So I have a bunch of points that I'm going to plot now. So the points I'm going to plot are negative 5, negative 1.26, negative 4, negative 1, negative 3.5, negative 0.79, negative 3, 0, negative 2.5, positive 0.79, negative 2, 1, 0, comma 1.44, 1, comma 1.59. I'm not plotting the point 104.69, but I could if I really blew this up. So negative 5, negative 1.26. I go to negative 5 on the x-axis and then down a little bit under 1. That's about there. And then negative 4, negative 1. I find negative 4 on the x-axis, go down to negative 1. That's about there. Negative 3.5, negative 0.79. I don't know why I picked this point, but that's about here. Negative 3, 0, right on the x-axis. Negative 2.5, 0.79 is about negative 2.5, 0.79. That's poorly drawn, but good enough. Negative 2, 1, 0. Did I miss a negative 1 something? I did. Negative 1, 1.26. I just missed it. Negative 1, 1.26 maybe is about there. 0, 1.44. That's not really plotted that well, but it's okay. And then 1 and 1.59. And then 104 somewhere's up there. So eventually this thing, it's very slowly, but when I get out to 100, it's already up at 4. And then similarly, very slowly, it keeps going down forever. So this is a reasonable graph. And then to find the domain in the range, for the domain, I have to find the left edge of the graph. The graph doesn't have a left edge like square roots, because square roots of negative numbers aren't defined, so I don't have square roots of negative numbers, but cube roots of negative numbers are defined. So this graph eventually works its way to the far left edge of the right x-axis, and it works its way to the far right edge of the x-axis. We'll say the domain is from negative to positive infinity. Turns out for us, for all cube roots that we graph, our domain will be negative to positive infinity. For the range, I need to find the bottom and the top of the graph. In order to really see the bottom and the top of the graph, I'd have to blow it way out, because at 100, the graph was up at 4 point something. It probably at 1,000, it's probably up at 6 or 8. At 1,000,000, maybe it's up at 100. It turns out that this graph eventually, albeit very slowly, it keeps going up and up and up forever. Eventually, it gets to the top of the y-axis going right, and eventually it keeps going down ever so slowly, and eventually it gets to the bottom of the y-axis. So this graph actually goes from the bottom of the y-axis to the top of the y-axis. And for us, for all cube roots, our range will be negative to positive infinity. And that's going to be the case for every single cube root that we graph. I won't even have to think about the domain or the range. The domain is going to be negative to positive infinity, because the graph goes from the far left edge to the far right edge of the x-axis. And the range is going to be negative to positive infinity, even though it won't look like it. But if we blew our graphs up far enough, it would go from the bottom of the y-axis to the top of the y-axis. Better start exploiting my, oh yes, I'm definitely going to exploit my calculator now. So I'm going to create a table of values, and I'm going to use my calculator because I don't want to do these tables by hand. I'm going to sketch a graph, find the domain and the range, and be done. So I'm going to do just what I did for the last two problems, but I'm going to do the table by myself. And how do I know what numbers to put in the table to get a reasonable graph? I'm going to just call this x and y as opposed to x and f of x. What I do is I take the number inside the parentheses or under the radical and change its sign. So I'm going to, for my table for all these problems, I'm going to change the sign of the number. It's not just what I just did, is it? I don't want to redo it. Oh yeah, I already did the square root of x minus 2. Let me make this the square root of x minus 3, because why would I want to do exactly the same problem? It's going to be exactly the same graph. So let me change this to f of x equals the square root of x minus 3. And then so for my table, I'm going to change the sign of the number under the radical. In this case, the number under the radical now is 3. And then I'm going to find that number on the x-axis, and I'm going to take 3 numbers that are smaller and 3 numbers that are bigger than it, and I'm going to make my table moving from left to right with those numbers. So smaller than 3, 3 numbers are 2, 1, and 0. Bigger than 3, the numbers are 4, 5, and 6. So always, for all the square root and cube root problems, I'm going to take the number in under the radical, I'm going to change its sign, and then make a string of 7 numbers, I guess. Eventually I'll get less, that have that number in the middle. And then I could by hand now go the square root of 0 minus 3, and I'd go the square root of 0 minus 3, error. So that's not going to be graphable. and then I could do the square root of 1 minus 3. Error again. That's not going to be graphable. And I can do that forever, or I can exploit my calculator, which I really want to do. Let me finish up a couple more of these. The square root of 2 minus 3. Hopefully, this strategy isn't going to blow my calculator up. If this strategy kills my calculator, if I go to do the table, then I'll refine this. But I think it's going to be fine on my calculator. So I don't want to do all these y's by hand, but I can. So I'm starting to get my table filled in. Each thing gives me a point. This is driving me nuts already, so let's get our calculators working. So first of all, please, 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 please get your calculator out and do exactly what I do. I'll try to go extra slow, because if you don't get your calculator set up properly, you're gonna get confused. So first of all, I'm gonna hit the Shift and the Setup key. So Shift, and then the Mode key gives me the setup. So please do this. You're going to regret it if you don't, or you're going to rewind the video and make this happen. And then arrow down till you find table. So I press the down arrow. Find option 5 that says table. So let me just clear this out. So what I did is I hit the Shift button, hit the Setup key, which is on the mode, press the Replay button down, and now I'm going to hit number 5 for table, and then select option 1. If you don't select option 1 right now, when we go to use the table fact on our calculator, it's going to mess you up. It's going to want you to enter 2 functions. So I select option 1. Done. Never have to do that again. So I did Shift, Setup, down, option 5, option 1, done. Now my calculator's ready to do tables. So how am I going to do a table on my calculator? It's going to be similar. So this is just only one time. This is just only, never again will I have to do this. This is just to get my calculator working. But now, for every table, I'm going to do this. I'm going to hit the Mode button and select the same thing that says table. So I'm going to go Mode, and then I'm going to click option 7. Last time I did Shift and Mode, which was different. This is just Mode only. So Mode only, select option 7, and then it asks me for the function. It gives me the function name, and I'm going to do square root of x minus 3. So I'm going to go square root, and I have to find that x, and that x is, seems to be hidden right now. That x is right there on the right parentheses key written in red. So I'm going to hit the alpha button and the right parentheses key to get the x. So again, so what I did is I hit the square root button, I hit the alpha key on the top row, and then the right parentheses key, and then the minus I need is a minus above the equal sign, and then 3. So that looks enough like the function that I feel like it's going to give me a good table. After I get the function in by hitting Mode, 7, and then square root, alpha, right parentheses, minus 3, I hit the equals button, and it says, where does your table need to start? My table is going to start at 0, so I'm going to type the number 0 and then hit equals. It says, where is your table going to end? My table is going to end at x equals 6, so I'm going to type in 6 and hit equals. And then it says step. Each of these are 1 apart. If I did like 0, 2, 4, 6, 8, 10, I would type in 2 because the numbers in the x column are 2 apart. If I did 0, 3, 6, 9, I'd type in 3 because the numbers are 3 apart. But my numbers are 1 apart. They're always going to be 1 apart. I'm going to type in 1 and hit enter. And it gives me the table. Look at what it's giving me right now. It says, if I arrow up here, I hate this first column. It says the first point is the point 0 error. The second point is the point 1 error. The third point is the point 2 error. If I arrow down more, it says the fourth point is the point 30, which I have. The fifth point is the point 41. The sixth point I don't even have. It's the point 5, 1.41. And the seventh point is the point 6, 1.73. So I'm going to exploit that for every single graph. I am never ever again going to do a table by hand because my calculator does it for me. So the points that I need for this are the points 0, error, which I can't graph that. 1, error, that's not going to graph as well. 2, error, no point for that. Then 3, 0, 4, 1, 5, 1.41, 6, 1.73. Graph those points and I'll feel good about this. Error, error, error. 3 zeros the first point, and then 4 ones my second point. 5 and 1.4 is my third point. 6 and 1.73 is my last point. I'm going to connect the points. I'm not going to go backwards from the 3 because I have a bunch of errors next to it. That's done with the graphing part of this. So I'm done with most everything. I created a table of values. I sketched a graph. I'm going to use my calculator, round to 2 decimal places. Now I need to find the domain and the range and interval notation. It's going to be real easy for the domain. For the domain, the graph starts on the x-axis at 3, and it goes off to the right edge of the x-axis, which is at infinity. For the range, I look at the bottom of the graph. The bottom of the graph is at the point 3, 0. The bottom of the graph, its y is at 0. And very slowly the graph works its way up, and eventually, if I make my window big enough, the graph works its way up all the way to the top of the y-axis. So the range is going to end at infinity. The more of these we do, the more you'll be able to rock on the domain and the range, because they're very repetitive. For, heck, I could do the cube root of x minus 2. I haven't done that yet. So now I'm going to do the cube root of x minus 2. I'm going to make my table of values, an x column and a y column. I'll take the number 2, put it in the middle of my x column, and then I'm going to go 1, 0, -1, going smaller than 2, and then go bigger than 2, 3, 4, and 5. So I always, for my table, I find the number inside under the radical, I change its sign and put it in the middle of my x column, and then go smaller by 1, bigger by 1, smaller than 2 is 1, 0, -1, bigger than 2 is 3, 4, and 5. Now I'm going to steal from my calculator. Steal from my calculator, I go mode 7, and then I'm going to do the cube root, so shift and square root for the cube root, and then the x is alpha in right parentheses minus 2. So there's the function I want the table for. Hit enter, starting at -1, ending at 5, stepping at 1, steal all the points. So the first point is the point -1, -1.44. The second point is the point 0, -1.26. The third point is the point 1 and -1. The fourth point is the point 2 and 0. So the numbers in the left-hand column just say first, second, third, and fourth point. The actual points are the second 2 columns. The fifth point is the point 3 and 1. The sixth point is 4 and 1.26. And the sixth and last, or seventh point is 5 and 1.44. I'm just going to plot those points the best I can. So the points I'm going to plot are negative 1, negative 1.44, 0, negative 1.26, 1, negative 1, 2, 0, 3, 1, 4, 1.26, 5, 1.44. So negative 1, negative 1.44, I go over to negative 1 and then down a little bit less than halfway. 0, negative 1.26, I find 0 and I go down. Oh, I messed up. 1.44 should be under the 1. So that point's no good because I need it to be under the 1 but not halfway between the 1 and the 2 about. And then 0, negative 1.26 is about there. It's 0 and then down a little bit under the negative 1. And then 1, negative 1 is easy for me to plot. 2, 0 is easy for me to plot. 3, 1 is easy for me to plot. 4 and 1.26, I go over to 4 and then up a little bit over 1. 5 and 1.44, I go up over to 5 and up just slightly under halfway. And I connect the best I can the points. Probably got a little bit steep on these, but that's fine. The domain, I put little arrows because the graph actually goes forever to the left edge and the right edge of the x-axis. So the graph for the domain goes to the far left edge of the right x-axis and the far right edge of the x-axis. The domain of all cube roots that we're going to graph are negative to positive infinity. And very slowly, the graph, as further out we go, the lower it gets. The further out we go to the right, the higher it gets. Eventually, the graph gets to the bottom of the y-axis, and eventually it gets to the top of the y-axis, depending which direction you're going. The range is going to be negative to positive infinity. And that's everything for problem part B here of whatever problem this was. And I'll move on to the next problem, 86, the square root of x plus 2. Just checking on my recorder to make sure it hasn't died on me because I've talked for too long. So what I'm going to do is take the number in the middle of the x column. Let me just do it all on here so I don't have to double up these. So for the square root of x plus 2, my table is going to start off with negative 2 in the middle of my table, because I take the number under the radical and change its sign. And then smaller than negative 2, I'm going to go negative 3, negative 4, negative 5. Bigger than negative 2, negative 1, 0, and 1. I just increment by 1. It's going smaller and bigger. I'm going to yank my calculator out to do a table. So mode, and then option 7. Now I'm going to do square root alpha, right parentheses, plus 2. There's the function I'm graphing, starting my table at negative 5, ending my table at 1, stepping 1, negative 5, I get an error next to it, negative 4, I get an error next to it, negative 3, I get an error next to it, negative 2, I get a 0 next to it. Negative 1, I get a 1 next to it. 0, I get a 1.41 next to it. And 5, I get a 1.73 next to it. You'll start to see similarities in my y values because of the way I construct my tables. So, first point I can plot is the point negative 2, 0. Everything else to the left of it is an error. And then negative 1, 1, 0, 1.41, 1, 1.73. Connect the points, but don't connect the error points, so I get a graph that looks something like that. So I've done most of everything. I've completed the table, sketched a graph. Now the domain, the graph starts on the x-axis at negative 2, and it eventually goes to the far right edge of the x-axis, which is at infinity. The infinities get round brackets because the graph doesn't technically get there. For the range, there is a bottom to this graph. The bottom is at the point negative 2, 0. The y-coordinate of the bottom is 0. Eventually, very slowly, the graph gets up to the top of the y-axis, so the end of the range is positive infinity. And that's everything for part A there. And I'm going to move on to 86, part B. And they're fast if I do them on my calculator. Table's going to be the same because the number of the radicals is the same. So for the cube root of x plus 2, for my table, I take the number under the radical and change its sign. So I change the positive 2 to a negative 2. Then I'm going to go smaller, negative 3, negative 4, negative 5, bigger, negative 1, 0, and 1. Now I'm going to do my calculator's bidding here. So mode button, 7 for table, shift cube root, alpha x plus 2, start at negative 5, end at 1, step 1. So next to negative 5, I get negative 1.44. Next to negative 4, I get negative 1.26. Next to negative 3, I get negative 1. Next to negative 2, I get 0. Next to negative 1, I get 1. Next to 0, I get 1.26. And next to 7, I get 1.44. Again, you start to see similarities in my y's just because the graph functions are similar and the way I fix my tables up are similar. So negative 5, negative 1.44 maybe is about there. Negative 4, negative 1.26 maybe about there. Negative 3, negative 1, that's easy because I just go left 3, down 1. Negative 2, 0 is there. Negative 1, 1. 0, 1.26 about there. 1, 1.44 about there. So again, best I can, I plot the points, and all cube roots that we're going to do, the domains go from the far left edge to the far right edge of the x-axis, so it's negative to positive infinity, and eventually it gets to the bottom and the top of the y-axis, and the range is always negative to positive infinity. So for every cube root graph, I don't even really have to think about the domain and the range. The domain is fairly obvious that it goes from the far left edge to the far right edge of the x-axis. It's not as obvious that eventually it gets to the bottom of the y-axis and the top of the y-axis, but if we made a big enough window, it would do that, get from the bottom to the top of the y-axis. So all cube roots, the domains are negative to positive infinity that we're going to do. The ranges are negative to positive infinity. It's the square roots that vary up a little bit. Oh, this is going to be a little bit different, but not so bad on my calculator, but a little bit different on the domain. This -1 outside the radical is going to mess up the domain little pattern that we're getting to, but that's all it's going to mess up. So for this problem, I'm asked to do the square root of x minus 2 and then -1. Still going to do the same thing for my table. I look at the number under the radical, I'm going to change its sign. Negative 2 goes to positive 2, and then 1, 0, negative 1, 3, 4, 5. So I always take the number under the radical, stuff it in the middle of my x column, and then by 1 go bigger and by 1 go smaller. And now I'm going to do my table. So mode button, 7, square root of x minus 2, and then replay a right arrow out of the radical and then -1. So that looks enough like the original problem that I'm going to believe the y's that my calculator gives me. Start at -1, end at 5, step 1, first point, error, second point, error, third point, error. Finally, I get 2, -1, and then 3, 0 for the fifth point, and then 4, 0.41, and then my last point, 5, 0.73. So those are the points I'm going to plot. I just steal them from my calculator. They're a nuisance to do by hand. So error, error, error. First point is the point positive 2, negative 1. Then the point 3, 0. Then the point 4.4. And then 5.7. This graph is going to look like that. And again, I'm not going to graph to the left of the errors. So, that's a graph. The domain, it still starts in terms of the x's. It starts at 2 on the x-axis in terms of the x's and goes all the way off to infinity, the far right edge of the x-axis. So the domain of this is going to be a square bracket on 2 because it starts at 2 on the x-axis. Anything to the left of 2 is errors. Ends at infinity. And for the range, this graph has a different bottom. The bottom point of this graph is the point 2, negative 1, and the y-coordinate of the bottom of the graph is the beginning of my range, which is going to be at negative 1. This graph, again, it very slowly goes up. Eventually it gets to the top of the y-axis. The end of my range is going to be infinity. So a little bit different. This minus 1 kind of messed up the table. Didn't mess up the domain, but it messed up the range. For part B, the cube root of x minus 2 minus 3 for my table. Probably messed up there, writing things where I wrote them. Let me just do this differently. I should write these a little bit lower. So the cube root of x minus 2 minus 3. Table's not going to be, the x's aren't going to be messed up on me. Take the number under the radical, change its sign, make it a positive 2, then by 1 get smaller, and by 1 get larger. Those are my x's. Now get my y's. Mode 7 cube root of x minus 2, get out of the radical, minus 3. Start at negative 1, end at 5, step 1. First one I get negative 4.44, and then next to the 0 I get negative 4.26. Next to the 1 I get negative 4. Next to the 2 I get negative 3. Next to the 3 I get negative 2. Next to the 4 I get negative 1.74. And next to the 5 I get negative 1.56. So those are the points I'm going to graph. Again, I just stole them all from my calculator because I don't like doing these tables by hand. So negative 1, negative 4.44 is maybe about there. I go to negative 1 on the x-axis and then negative 4.44 on the y-axis. And then 0 on the x-axis, negative 4.26 on the y-axis. And then 1 and negative 4, 2 and negative 3, 3 and negative 2, 4 and negative 1.74, 5 and negative 1.56. I don't know how well I graphed those, but well enough, I guess. So not a stellar graph. I probably could have been a little more careful plotting my points, but it's good enough for what we're doing. And for all cube root functions, I don't even have to think about the domain in the range. The graph goes clearly from the far left to the far right edge of the x-axis, and not as clearly and very slowly. It eventually goes to the bottom and the top of the y-axis. The bottom of the y-axis is at negative infinity. The top of the y-axis is at positive infinity. All cube roots, I'm going to do the same domains and ranges until maybe, I don't even think in college algebra, you get twists on this. I think just a couple more problems. So I'm going to do 90 and 92. Oh, 92 is going to be a little bit tricky. Let me just skip 92 and not get into the trick. So you can skip 92. If you want to see the little trick when you get something a little bit different under your radical, I'll I'll show you. The trick would be, my table's not going to be the same. My table is going to have 5 in the middle of it. To figure out what goes in the middle of it, I'm going to set what's under the radical equal to 0, and that's going to give me 5. So my table is going to be 5, 4, 3, 2, 6, 7, 8. Not going to be on the test. Let's just skip that and end at 90. So for 90, the square root of x plus 2 minus 2. My table, I'm going to throw a negative 2 in the middle of it. I change the sign of that and do negative 3, negative 4, negative 5, negative 1, 0, and 1. Work on my y's now. So mode table square root of alpha x plus 2 out of the radical minus 2. Didn't get out of the radical minus 2. Start at negative 5, end at positive 1. Step 1, error, error, error. Negative 2, I get negative 2 next to it. Negative 1, I get negative 1 next to it. 0, I get negative 0.59. And 1, I get negative 0.27. And so the best I can now, I'm just going to plot the points. First point I can plot is the point negative 2, negative 2, and then negative 1, and then 0, negative 0.59, 1, negative 0.27. So the best I can, plot those points, connect them. I don't go backwards because of the errors. So there's a reasonable graph for the domain. This starts at negative 2 on the x-axis and goes off to the far right edge of the x-axis. So the domain is negative 2 to infinity. For the range, this point right here is the point negative 2, negative 2. So the graph starts in terms of y's at negative 2, and very slowly it works its way up to the top of the y-axis, which has an infinity. All right, I think about to do the last problem we're going to do today, and that's going to be the cube root of x plus 2 minus 5. So let's do that. So the cube root of x plus 2 minus 5. For my table, take that 2, change it to a negative 2, then do negative 3, negative 4, negative 5, negative 1, 0, and 1. And now my calculator, mode 7, shift cube root, x plus 2 under the radical, and then minus 5. Start at negative 5, end at 1, step 1. First point is negative 6.44. Second point is negative 6.26. Third point is negative 6. Fourth point is negative 2, negative 5. Then negative 1, negative 4. And then negative 3.74. And negative 3.56. 3.5. Oh, that's right. It was just surprising me. Now I'm going to plot those points. First point, negative 5, negative 6.44 maybe is about there. And then negative 4, negative 6.26 maybe is about there. Negative 3, negative 6 is easy. Negative 2, negative 5 is easy. Negative 1, negative 4, easy. 0, negative 3.74. And 1, negative 3.56. Again, they're not perfectly graphed, but they're graphed well enough. So I'm done with the graph. For the domain, the graph extends from the far left edge of the x-axis, which is negative infinity, to the far right edge of the x-axis, which is positive infinity. The range of these isn't as clear, but eventually it gets to the bottom of the y-axis, which is negative infinity, and to the top of the y-axis, which is positive infinity. So my calculator's in graphing mode right now. To get it out of graphing mode, because you're going to want to use your calculator for something else, just hit the mode button and type number 1. So if you've just done a graph, had a table there, just hit the mode button, type the 1, and it'll put you in modes where you can do all your other computations. Okay, so that's that whole section. Hopefully that didn't feel horrible. A lot of calculator work, and generally that's, not a bad thing. Again, visit me if you want to see 44 through 54. I will definitely do those for you if you want to see the theory that I skipped over.